All right, here we go. So he climbed. What's this? So we've done that one. All right, so now let's look at problem number 9. Okay, so notes here. So I'm gonna give you 2 sets of notes. The 125 meters. That looks awfully dark, doesn't it to you? Doesn't that look dark? I'm going to leave last semesters up there also so that you can take a peek at them. But wow, this seems awfully dark to me. There we go. There we go. I knew there had to be a brightness thing. There, that's better. All right, so now, so he's up at mg. So remember, the energy before is equal to the energy after if we neglect air resistance and all that stuff. So his energy, his gravitational potential energy before is mgh. And his energy after is all kinetic energy, which is 1/2 mv squared. So this is problem number 9. Well, look at that. Notice I didn't give you a mass or anything like that. I guess you could have calculated. You could have put in an 85 if you wanted to. We know the height. And we know G, so you could just say, well, this number is equal to that. But let's not do it that way. Let's just multiply both sides by 2. So if I do that, I get 2 mgh is equal to 2 times 1/2 mv squared. So this stays as 2 mgh, and this comes boink, boink, and so that becomes mv squared divided by m. So we get 2 mgh equals mv squared. And so when I divide both sides by m, boink, boink, those divide out. So you get 2gh is equal to v squared, both sides. Take square root of both sides. So that little algebra, you thought, oh my God, I'll never use this. But there you go. So you got 2 times 9.8 times 125, and you take the square root of it, and you should get the velocity that hit the ground. Okay? Not bad. Not bad. Smacks a slap shot at 106 miles an hour. Convert that to meters per second. We've got our nice little conversion thing we can use, or you can do 1609 divided by 3600 seconds, 1609 meters. Okay, using the mass of the puck and the answer above, find the kinetic energy of the puck. Oh my goodness, I think we've done that. Kinetic energy is 1/2 mv squared. The hockey player hit the puck shot from 17.6 meters from neglecting any deceleration. That was just for the physics folks out there. How many seconds did it take for the puck to reach the goalie? The distance is equal to the velocity times the time. So you got to find the time. You're given the distance. So here we go. Let's look at 10, 11, and 12 real quick on this, and then we'll go on to the next slide. All right. So 10, 11, and 12 look like this. MG8 or 106 point, what was it? 106 miles an hour. So we got 106 miles an hour. Convert miles per hour to meters per second. We've got a conversion thing for that. So all you got to do is multiply, because if I take 1609 divided by 3600, because there's 3609 meters in a mile divided by seconds in an hour. Then if I've got miles over 1 per hour over 1, then that cancels that. See, all these cancel, and I wind up with meters per second. So that's how we get that number. All right, and then 11. Where the hell did it go? Oh, here it is. 11 says, find the kinetic energy. So 11, here's what we're talking about. 1/2 mv squared. That's the kinetic energy. You just found V. You're given M. And then problem 12, if he whacks it that hard, and we're going to say over the short distance that it traveled on the rink, 17.6 meters, over this very short distance, we're going to say it didn't deaccelerate, it didn't slow down. So it kept a constant velocity for this. So distance equals that. So here's what this looks like. So distance equals velocity times the time. Well, you found the velocity in problem 10. The distance is equal to 17.6 meters. Okay, I don't know why I put that thing there. And then if I take distance divided by time, I get the velocity, but I need the time. So if I take the distance divided by the velocity, I get the time. Okay?